Hello. In this video, we're going to go over graphing a sine graph while using the chart method. The first thing we need to do is factor this out into the form of a sine b x plus c plus d. So we're going to need to factor out that 3 in order to see our phase shift, in order to list this transformations nice and neatly. So yeah, that's what we're going to look for. I'm going to make this smaller because it's not really that important. So let's take out that 3. So we're going to rewrite this. Y equals -2 sine. We're going to bring out the 3. And what does that mean when I bring out the 3? Essentially, I'm dividing by 3 or multiplying by 1/3. So we see this is going to be -pi/6 plus 2. Again, just so you see that on the side, we took the pi/2. I divided it by 3, but we know that just means multiply by 1/3 to get our pi/6. Okay, now we're going to list transformations. The first transformation we look at is this guy right in front. This is a horizontal stretch or shrink. And this is a shrink. So when our b here in this situation is greater than 1, the absolute value of b is greater than 1, we have a shrink. And when the absolute value of b is between 0 and 1, like a fraction smaller than 1, we have a stretch, which is going to be the exact opposite of how a responds. So we're looking at this as a horizontal. Whoa, I wrote that so terribly. Let's do that again, huh? We have a horizontal shrink by a factor of 1/3. Next, we're going to look at, well, the other guy that's inside of our parentheses, and that is going to be a horizontal shift in the left or right department. Horizontal shift, and you just flip the sign. So this would seem like -pi/6, which just means I'm going right pi/6. Then we're going to have 3. Well, we're going to make these obviously a little smaller together. Then what we're going to look at is the outside of this guy. And we're going to look at this number here, our A. And like I mentioned before, when the absolute value of A is greater than 1, we have a stretch, the opposite of B. And when A is between 0 and 1, we have a shrink. So those are the rules there, so you can see them. So we're looking at number 3. We see if it's a 2. So we have a vertical stretch by 2. The next thing we look at is the negative sign in front of the 2, and that will be a reflection across the x-axis. Reflip, that's not purple. Reflection across x-axis. Lastly, we look at our +2 at the end, and we see that is just our vertical shift up 2. So that one does not change signs. All right. Next, it's time to start the chart. So let's make sure that's all nice and neat. It's all nice and neat. All right, let's make our chart. So first we have our origin, right? Then we're going to have our, we're doing our horizontal shrink, so 1/3 x. And we have our horizontal shift right, which means x plus pi/6. That means we can move this over a little bit. We don't need that much space between each one. X plus, we might need space for this one. X plus pi/6. Then we're gonna have a vertical stretch by 2, just 2y. So let me explain this as I go, a little more clear. So our origin, we started our origin. Then we apply our transformations individually. Our shrink applies to our x value, so we're going to times our x by 1/3. Our horizontal stretch applies to our x value, so we're going to add 1 pi over 6 to it. Next, we look at our y value. And because we're going to be taking a vertical stretch, so we're going to multiply that guy by 2. And then we're going to take our reflection, which just means just take your y, make it negative. And then finally, we're going to take our y and add our vertical shift, which is +2. We don't need that much line. Perfect. Now, in order to find these starting positions, all we need to remember is our starting points and what degrees we have at each of those points. Let's graph this with a green graph. So here we go. We know that this is 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So the next thing we need to do is remember our points on those graphs. I should have wrote them better. Let me write the points down first so it's less confusing. So here is this point, which is 1, 0. And this is at 0 or 2 pi. Put 3 pi over 2 below. Put pi over 2 above. Put pi over here. This is 0, 1. This is -1, 0. And this is 0, -1. So our starting point for sine is our y values in this graph. So we have 0, 0. Then we have pi over 2, 1. Then we have pi, 0. We're looking at the y values. Then we have 3 pi over 2, -1. Oh, whoops. And then we have 2 pi, 0. If you think about it, starts the middle, goes up, back to middle, down, back to middle. So perfect. It's exactly what we want. Let's separate them, make our graph a little cleaner. Let's put this down for a second. Keep making it cleaner, keep making it cleaner. And now let's start applying all of these transformations. So the first transformation is we are multiplying 1/3 to x. This does not change. Next, we add pi over 6 to x. So 0 plus pi over 6 is pi over 6, 0. Y does not change. Multiply 2 to y. Nothing changes. Multiply negative to y. Nothing changes. Add 2 to y. This is now my new starting point. Pi over 6, 2. 2 is a little weird looking. 2. Same thing here. Multiply by 1/3. So now we have pi over 6, 1. Add pi over 6 to pi over the x value. So we'll take it over here. 1/6 plus 1/6 is 2 over 6, which is equal to 1/3. We'll call that pi over 3, 0. Oh, wait, 1. Sorry. 1. Multiply the 2 to the y. Pi over 3, 2. Flip the sign of the y. Multiply it by negative. Pi over 3, -2. Add 2. Pi over 3, 0. That is my next point. Okay, next. Pi times 1/3. We have pi over 3. The 0 will stay. We know for the y. So then pi over 3, we're going to take our 1/3 plus our 1/6. We know that 1/3 is 2/6. So 2 is going to be 3 over 6, which is going to be 1/2. So we're going to take pi over 2 now, 0, because we just added that pi over 6. Multiply y by 2, doesn't change this y. Flip the sign of this y, doesn't change this y. Add 2, and there we go. So far, so good. Next, we're going to multiply this by 1/3. So 3 over 2 times 1/3. Just going to cancel that. We're gonna be left with 1/2, so this is gonna be pi over 2. And pi over 2, -1. We're going to take our pi over 2, which is 3/6, plus 1/6, which is 4/6, which is now 2/3. Add the pi. 2 pi over 3, -1. And then we're going to multiply the y by 2, 2 pi over 3, -2. Flip our y sign, +2, add 2, 2 pi over 3, 4. Last point, and then we can graph this guy. All right, so 2 pi over times 1/3 is 2 pi over 3. The 0 stays. Now we have to take 2/3, which we know is 4/6 from what our math above, plus 1/6 is just 5/6. We have 5 pi over 6, right? The 0 will stay, times by 2 to the y, so the 0 stays. 5 pi over 6, 0 stays. 5 pi over 6, 2. Okay, so now we have all of our points. We are going to graph our graph and be done with this type of problem. Move this up here a little bit. Let's make our graph. So we know everything's positive, so we don't need any negative values. So we can just ignore that part of the graph. Next is a personal preference of mine. I like to rewrite midline and amplitudes with dotted lines, just it helps me see things. So we know we're going up 2, so 1, 2, so this is 2, this is 4, this is 0. Our 2 is our new midline. Our 4 is our maximum value. Our 0 is our minimum value. We just need to plot the points now. We have pi over 6. I'm going to make it every 3. Pi over 6. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. Then we're going to plot our points. Pi over 6, 2 is here. Pi over 3, 0 is here. Pi over 2, 2 is back here. 2 pi over 3 is up. 5 pi over 6 is back. And we have our wavelength. As you can see, this method takes twice as long as the other method. I strongly advise the other method. However, if this is how you understand it, by all means, please. If you'd like me to do a different type of sine graph, please just send me an email. Other than that, I hope everyone has a great day.